Good morning, everyone. Thanks to BME Plus for giving me the chance to present my dissertation work, which is for the comparative analysis of construction approaches towards industrialization, traditional versus total prefabrication. This was conducted under supervision of Professor Isabel and co-supervision of Eng Miguel Pérez from Casage Group. The research outline is introduction, literature review, framework, case study, and concludes with the conclusion. For the introduction, here is the research scope, which is a main comparison between offsite construction and traditional construction by using the technology of building information modeling to quantify the benefits of using one of these type of construction throughout the suggested case study. Here is the research objectives, which is to have the knowledge on offsite construction and on the different types of offsite systems to identify the potential benefits and the challenges of using offsite construction, to clarify the technology of BIM, to establish a framework to enable a 4D comparative analysis for the two types of construction, and to develop a 4D BIM based analysis and apply this analysis on the case study. For the research structure, chapter 1, which is the scope of the research, chapter 2, which focus a review of literature for the main topics. Chapter 3 develops the theoretical framework, and chapter 4 develops a 4D BIM comparative analysis with application on the case study. And chapter 5 summarizes the important facts and conclusion. What is offsite construction? Offsite construction is the method of construction that comprises the planning stage, design, fabrication, transportation, and assembly of prefabricated building components on site. And here is the size of global offsite modular construction market that shows in the figure, and it has annual growth rate of the offsite construction that's indicated by Construction Industry Institute with annual growth rate 9.6%. There is four types of offsite construction: volumetric construction, panelized, hybrid construction, and sub-assemblies and component system. All of them need to be manufactured in factories and to be transported on site to start the process of assembly. For the key benefits of using offsite construction, less time is spent on site, less manpower required, less waste produced, and construction of site decreases the traffic and improve health and safety measurements. For the challenges, it requires accurate planning. There is properly transportation challenges and insufficient worker skills, lack of guidance and information, and it needs excessive coordination. For the traditional process, it's starting with planning, then passing by with design and engineering, procurement, and starting the construction process on site by material production on it. And if you assign this process on a timeline of the project, start with the design stage and begin the on-site construction after ending this design stage. For the off-site construction process, planning stage, design and engineering, procurement, all of them needs to be started at the same time to assist the factories to start the process of fabrication and to transport all the elements and starting the assembly process on site. If you assign this process on the timeline of the project, the design stage is a bit longer, and make the on-site construction to prepare the site for receiving the components of the elements, and starting the off-site fabrication of the factories, making the connection and transport all the elements to starting the assembly process, and probably there will time saving at the end. According to building information modeling and according to Eastman curve, by using a conventional workflows, there is a lot of loss of information caused by using these conventional workflows. That's why we are using digital workflows. And according to Michelini's curve, the BIM-based planning process has a shifting earlier in time, according or comparing to the conventional planning process, and that may probably cause changes in cost. The main scope of this work is the 4D simulation for the offsite construction, and the 4D, which is the 3D geometry, and additional on it the time schedule. And the first thing needs to define the level of information need to start this BIM use. And the benefits of using 4D simulation is 4D modeling is visualizing the task, improving the site works, and increasing the productivity. For the upcoming two chapters, begins with comparison with traditional elements and systems that is using to as a total prefabrication and making the macro workflow, then propose a 4D framework which is going to be applied on the suggested case study with the two types of construction and quantify the benefits of the 4D comparative analysis of using of these construction methods. All of us is familiar with traditional construction is reinforced, such as reinforcement concrete, columns, slabs, beams, and sheave walls. The way of construction of using this type of construction needs equipment, labor, such as concrete bump, concrete mixture, concrete preparator, as well as carpentry crew for fixing the formwork and dismantling, concrete crew, and people's crew. And one of the advantages of using this type of construction requires less trained labor, and although the disadvantage of it requires a significant amount of labor. For the key system, which is using as a total prefabrication, it needs to define first the key grid that is going to use for each floor and key columns, which has a vertical stresses coming from upper to lower, a hybrid slab panel, which is mixed with concrete and wood, which is advised to be exposed in the interior face, and facade elements and central girder, which supported the hybrid slab panels on the other side. The way of construction of using key system needs a portable crane to carry the elements and a trained weld crew for making the connections. One of the advantages of using key system has a greater productivity per day and less dependent on site. On the other hand, this advantage, the distance between the factory and construction site needs to be considered. Prefabricated elements need to be handled with a proper care and precautions. As macro workflow for the goal of the research, we need to define the database that is going to be used to start the 3D modeling, export the IFC to start the 4D modeling in any 4D software, making the 4D simulation by assigning the schedule for the work, and reaching the 4D comparative analysis between the two types of construction. As a micro workflow, the right side, which is the workflow inside Pexel, to reach the 4D simulation in the prefabrication way, and for the traditional, the left side is the workflow inside Pexel to reach the 4D model and 4D simulation. This case study is proposed by Casais Group. It's a B&B hotels located in Guimarães, Portugal, and the key systems that is used is 4,100 meters square. As the scope of the work will be only the two buildings that is going to be used in reality with key system, and it will be only the structural skeleton of the two buildings and their exterior envelope. The workflow to make the 4D simulation for the traditional model inside Pexel, starting with the federated model, and making the custom breakdown structure based on the created work breakdown structure inside Revit, and making the quantitating of cost classification and doing the intelligent schedule based on the intelligent engine inside Pexel, which needs to define zones and methodologies, and making the 4D simulation. And here is an example how the user can select all the structure works and architectural works by creating this custom breakdown structure that is going to help him to start the 4D modeling. And here is a workflow from Revit to Pexel Manager to define the level of information needs that is going to help the user inside Pexel to assign the elements to the schedule. For the traditional 4D model by using the intelligent schedule in Pexel, the user needs to create the zones. Zone 1, which is the project, methodology, which is the work packages between architecture and structural, methodology level 2, which will be the work packages such as structural work packages, such as slabs, beams, columns. And methodology level 3 will be the individual works inside work packages. And zone level 2 will be the building stories. And zone level 3 will be the horizontal spatial distribution, which is hotel building, then go to housing building. And here is the workflow inside Bexel to create the methodologies and creating zooms and define the relationships between the work packages and each individual work inside work packages. So the Gantt chart is generated as well as the line of balance, and the user can export the whole Gantt chart to facilitate the process of 4D modeling. And here is zoom in, showing the relationship between hotel building and house building, and how the user can insert the resources inside Vexel to know the the resource levels. And here is progress of work and the sequence of work for the traditional animation per week. So the case study by using tree system, the user needs to define the custom breakdown instruction inside Bexel and make the custom selection sets and make the schedule based on creation rules with logical relationships between these selection sets and creating the schedule and making the 4D simulation. And here is the workflow from Revit to Bexel by creating the attributes that is going to facilitate the user to start the 4D modeling. And here is an example for the custom breakdown instruction inside Bexel to reach the lowest level of elements that is going to be constructed in the cell. And here is defining the relationships between selection sets to create the schedule. So the Gantt chart as well as the line of balance is created, and the user needs to define the resources that is going to be used inside Bexel. And these figures show the progress of work per day by starting the process for hotel building first and go to start the erecting of housing building. As a result for the selected scope of the work, if the building is going to be constructed with the traditional way, it needs 107 days. On the other hand, it needs by using pre-system 16 days, and the work hours that is needs by using the resources, it will be in case of traditional need 36,160 work hours, and in terms of free, it needs 5,414. And here is video showing can you see the video?
No, we can't.
Okay. Sorry for that. So now we can see the video, right?
Yes.
Okay, here is the sequence of work by using the traditional way of construction for the case study. And the housing building follows the hotel building. And in terms of using three methods, starting with the hotel building, then going to start the assembly process on housing building. So as a conclusion, offsite construction is a good potential solution for many housing commercial projects to reduce construction time. Using tree system guarantees agreed time saving. The traditional schedule can be created by using the intelligent schedule inside Bexel. And for the prefabrication, the construction must reach the lowest level of the elements that is going to be construction site. And the purpose of both 4D models is achieved by using the advanced and the advantage of using Vessel Manager. For the future research, it is recommended to develop a 5D comparative analysis to evaluate the costs, and the prefabrication industry may employ additional sensing technology in addition to RFID technology to create a comprehensive construction management system. Types of construction requires highly coordinated and organized data exchange. In total, prefabrication construction logistic management is essential to meet the project objectives on cost, time, and safety. Sorry for my voice because I have COVID actually, but thank you for this chance to present my work.